Hi, good morning, and welcome to the ZP SenseItAll webinar. So we like to do these live streaming webinars every month, and it's really just a kind of commitment to SenseItAll. So I think this is particularly relevant to people who are either in academia, are interested in making products, or are what we call entrepreneurs in companies that are interested in making new products, or entrepreneurs who are interested in starting businesses that making products. Now, when I say products, I should really, strictly speaking, sort of talk about electrochemical biosensors. But rather than me talking about that, let me sort of jump into this a little bit more. And it's also just to say that it's not just talking, by the way, we do have a live demo as well. And anyone who's registered for any of our webinars, even if you don't take it, so even if you can't make it, I should say, we will send you a recording afterwards. So let me go forward a little bit more. It says here sensor to APIs, and sensor to API means sensor to application program interface. So if you're thinking about making a product, especially in the sensor space, it's probably good to be cloud enabled. I mean, this is going to be the sort of infrastructure that the modern world runs upon, which is APIs, all talking to one another, kind of making the modern world work. When you make contactless payments, it's all basically made through APIs. Just a quick introduction to Zimmer Peacock. My name's Martin Peacock, and I've got my colleague Garner here today. Garner is one of our senior engineers. And as a company, we were launched in 2014, so this is our kind of 10th year. We are ISO 13485, so we're particularly qualified for the development and manufacture of electrochemical biosensors. But this also means that we're very good at translating this kind of science and technology into other application spaces as well. We'll probably talk about environmental and food testing today. We do have some facilities in Norway and the UK. The team is fairly large and international, and the Norwegian facilities are large and really state of the art. And our R&D facilities are sort of, so we have both manufacturing and R&D facilities in Norway, and we have R&D facilities in the UK as well. The platform I'm going to talk today, now at ZP, we're sort of synonymous with electrochemistry, but we realize that not everything is electrochemical. Most things you can do spectrochemically, you can actually do electrochemically, but for whatever reason, maybe the assay exists in a spectrochemical format rather, and we can do that. But I will today focus actually on this middle picture here, which is the electrochemical OEM platform. OEM, by the way, always confused me when I first started my career. It just means original equipment manufacturer. And it kind of means that somebody may make something which you ultimately go on to sell, but the person may be making the first hardware that in that case us, that would make us the original equipment manufacturer. Don't worry if you've just joined us slightly late this morning. After this, we will be processing this recording and sending it on to you anyway. The other piece of technology that we do have is wearables as well. I would say, kind of in order of difficulty, making the spectrochemical and the electrochemical OEM, sorry, these platforms here, when I say here, the ones on the left-hand side, making spot tests, or when you just make a measurement and the measurement is over, those are quite straightforward. The one on the right-hand side, which is wearable, is much harder. I'd almost say 10x harder than trying to do individual testing. So I am going to focus today on the middle one here, which is this electrochemical technology. And just to say that this is kind of the hardware. Garner will take you through the hardware in a minute. It works with our screen printed electrodes and our biosensors. So at ZP, the first thing that we did when we were starting up the company was actually, we wrote it on the, almost on the first page, was, that we saw there was a lot of technologies that were developed in the world, both, in industry, but particularly in academia, and they weren't making it to market. And so we tried to reduce all the problems, I would say, between an idea and actually getting to market. Now, in academia, they call this the kind of the valley of death, that you've got academia and you've got commercialization and people are not translating technologies across. Well, at ZPC, we made a platform now that's actually quite low cost. It involves a low cost manufacturing platform, and it's actually it allows science to be translated into products really quite readily. What's nice, and the nice features about this, is when I say no more slots, if anyone's dealt with this kind of hardware, you're often trying to slot this sensor or the screen printed electrode into the box. It's an awful customer experience, and it comes from the glucose strip world, which I understand why it's there because it's low cost, but actually it's quite hard to do. And in many markets actually where they're not quite so price sensitive, you don't want that kind of slotting in. It's quite horrible, and as a R&D practice, I think it's quite horrible, and also it ends up wearing out the connectors really quickly. So there's lots of problems with these slots. This allows us to have this elegant cartridge. You'll see Guyana today, she doesn't need to align the cartridge is self-aligning. You'll see it's very cleanable. So if you're going to give a product to a real people, they're not going to treat it like a scientific instrument. They're going to end up spilling things on it, making a bit of a mess. So you'll see the way we can just take this apart and clean it. Something that you don't see happening is that thinking of user experience, but the user experience is really guided. There's some LEDs on the front of this, and Guyana will talk you through this today. But notice that every time the machine is in a different state, the LED will change kind of from blue to flashing to green to white. So it's guiding you through the user experience, or rather, users being guided through this as well. It's compatible with Apple and Android. You do not, getting an app onto Apple is not the world's easiest thing, let's say, but you'll find out that actually we've already got the app on Apple. So if you come onto this platform, you can say to people, oh yeah, I'm already on Apple and Android, and you'll see how we can just program the meter with a second QR code. So you'll see two QR codes today. One of them is to get the app onto your smart device. So if you've got either an Android or an Apple phone, kind of have it ready because a QR code will jump up in a bit. So what happens is the first QR code will install the software, and then the meter will actually say, well, the app will then say, well, what do you want me to measure? And then it's looking for a second QR code, which I'll also put up today as well. And if you later on want to watch this, if you've registered or you're attending now, I'll send you a video anyway, and you can sort of try it for yourself. It's cloud enabled. This cloud enabled is really important because being cloud enabled means that every time somebody runs a test, that raw signal is going to the cloud. So I support people in India and I support people in California and sort of both ends of the kind of the time zone, let's say. And because all their raw data goes to the cloud, it makes it really easy for me to support and troubleshoot. So if you're either making a product or you're supporting a product development, being able to get the data um, from the field and real users in real time is really useful because you can troubleshoot. There's nothing worse than the email that says it didn't work and it's like it didn't help you. But if you can see the raw data, it really helps you. There's also something called order fulfillment here. So what I mean by this is when you're starting any kind of business, actually getting products to customers is really quite something. You have to kind of sometimes have like 5 people just to sort of do logistics and shipping and dealing with payment, etc. You'll find that ZP's built a model where actually you can just instruct ZP to ship it and it will just go. We'll also price this for the OEM market. So what I mean by pricing it for the OEM market is that if you were to buy 10,000 units of this from us, it's 60 euros each. I had somebody today say it's too expensive. I was like, wow, 60 euros each is, it's too expensive. It's like, but there you go. So it is priced to be aggressive and get onto the market, but you need to make the 10,000 units. But that's actually quite standard in business. You don't get low price until you go high volume. And this is the thing that startups, struggle with a little bit. And it's also compatible with microfluidic cartridges. The next webinar, so if you find this interesting, if you've got colleagues you think would find this interesting, then we've got another webinar like this one. But each webinar actually progresses and we change materials. So, it's not like a repeat. It's actually, there's always something new. That'll be on the 27th of February, 2024, just FYI. Now, the philosophy at ZP is this. I've sort of alluded to the philosophy a little bit with this. So things that are important these days are water quality, healthcare, environmental monitoring, agriculture, food quality, food safety. These are the kind of things that are interesting. So there's a bunch of people with a bunch of needs. And I'm thinking about either patients or I'm thinking about farmers. And I'm also thinking then on the left-hand side here, we've got people who are in business or in academia, or just entrepreneurs, and they want to develop solutions. And these are, thinking in particular biosensor solutions for the people on the right-hand side. And as I said earlier on, I said it, now I'll show it, that there's a gap between actually you having an idea and you able to give them something quite tangible. And that's what the SenseItAll is really intended to be. It's like a unit with sensors that you can give to people, and they can actually start using it. Now, that sensor that you possibly have actually developed yourself may not be perfect, or the application may not be perfect, or there may be something confusing that makes it hard to do. But it's good to actually get something to somebody and actually start getting them to test it. Otherwise, you can spend years testing and refining and then find all the problems. And I've seen that quite a few years. I've definitely seen companies that have been well funded for 15 years finally never make it to the market when really they should, because really the market didn't want their product. So getting something to alpha and beta testers early is really valuable. So you get something to them, you get the sensor, you get the application, you get the hardware to them, and then they're testing in the field, and the data is going to the cloud. And that means you can look at that data and make sure that everything's working okay or improve things. By the way, our cloud does have an API in it, an application program interface. So if you want to bring data across to your cloud, you can make API calls upon our cloud, and that will happen. And then the idea is that you can see the data coming from your users, and you can start to improve things like sample preparation, maybe signal or information extraction out of the signal. You can improve the sensor itself because it's just not repeatable enough. But you're in this cycle of giving people real materials. Your alpha and beta testers, it maybe even customers, and then giving you feedback, and you're basically improving. And this is kind of the lean startup mentality. There's nothing new about lean. It's been around for sort of 10 years. But it's not always applied, and not everyone's ever heard of it either. So this is the kind of philosophy that we have. So trying to get people to market as quickly as possible, and to get rid of all this kind of perception that, you have to kind of build all this technology from the base upwards. You don't. I think we're part of what's called I would almost describe this as the no code movement. SenseItAll. So this is the SenseItAll platform. You can see it's quite a nice, elegant technology, and it can actually do. This is getting into the science of things a little bit, but it can actually do amperometry, it can do potentiometry, it can do voltammetry, and it can do impedance spectroscopy. So it's pretty enabled. What we're trying to do as well is get our academic colleagues onto this as well, because essentially today, by the way, I do own four CH instruments myself. I've got them in the garage. I'm not using them at the moment, but we do have them. So I'm not criticizing the instrument. What I am saying is these kind of instruments really confuse students, PhDs, postdocs, because it makes them think that their experiments are a long way away from being actual products. And so that's why we're introducing Kate. So Kate is really a potentiostat that's exactly the same hardware as actually SenseItAll, except it's much more of a scientific experience, because then you can mess around with parameters and do your kind of normal electrochemical experiments. But the hardware is exactly the same as SenseItAll. So that translation of what I did in the lab to what actually I can sell as a product is, the barrier is suddenly much, much easier when you're when you're doing your work on a potentiostat like this. You mentally can't get your head that actually what you're doing is actually really applicable. But when you're working on that kind of platform, it's very applicable. I was talking to an academic yesterday, and he's kind of like, no, I get it. This is if I'm working on this potentiostat, I'm really got the mindset I'm working on a product. But when I'm working on a potentiostat, I'm stuck in my R&D mode. And what's nice about it, as I say, we can do that at 60 euros each. Oh, I put US dollars here, but 60 euros each, as long as it's in 10,000 units. Otherwise, it's about it's 1,699 euros. Here's a link that might be useful, and here's some other links. I'll put the links, when I put this video online later on, I'll put the links underneath it as well. You'll see this run today, that actually, the way these platforms work, we have sensors and we have meters, we have various sensors, and we have an app. The app will tell the meters what to do. The meters will give the data back to the app. The app will give the data to Julie, and you will get a result on the smartphone. And you'll see Guyana doing that. But also at the same time, then all the raw data goes to the cloud. Now, I can't see that raw data. It's behind your username and password. But if you then want to share it with your other collaborators, you don't have to send them files. You can actually just invite them to what we call clusters and reports, so other people can see it, but only if you decide to share it. It's not obligatory to share it, just say. And again, there's an API on this, so you can bring this data across to your own cloud as well. The video here is actually showing the hardware, but you'll see Garnis discussing the hardware at the moment. The video up here is actually showing how we scan the QR codes, how we run the assays. It's how we actually can then go online and actually visualize the data, which is what the engineer is doing here, but you'll see that. And then this video here is, now if you've got your Android phone, I mean, admittedly, you might be watching this on your phone, which is a bit of a problem, but there's a couple of QR codes coming up in a minute, and those will sort of guide you into actually being able to install this app. But what's happening here is we've got the app installed on our phone by scanning different QR codes. It tells the app, what am I actually going to do? Am I actually going to measure a ginger sample, or am I actually going to measure a chili sample? So most of our biosensors now, I should update this file, but we're currently enabled glucose. We're currently enabled pH. We're currently enabled potassium, and also TAS, which is total antioxidative status, which is here. And we've also got another two, chili and ginger, on here as well. So most of our sensors we're actually able to enable by QR codes. It's probably worth saying that even if we have a sensor, if it will work in your application is a different question, see, because every application, the concentrations can be different, the matrix can be different. Is it freshwater, seawater? Is it sewage water, for example? You know, those matrices can be very different. So there does have to be a bit of a conversation about this. What makes all this work really well is actually the fact that we do the screen printed electrodes ourselves. They're really, really repeatable. This is the biggest problem in academic science and startups trying to make disposable biosensors, often the repeatability of manufacture of these sensors. The reason these sensors are so repeatable is because the biggest consumer of these sensors is Zimmer and Peacock. We use these day in, day out. We really watch the quality in them, and the first people to suffer if the quality is not good is Zimmer and Peacock. So we are definitely the chef in this kitchen, and we are eating our own food to make sure that it is actually good. So if you're on an Android, if you scan this QR code, it will take you to the Android store and, the Google Play Store, and you can install this SenseItAll app. At the same time, if you're on an iPhone or an iOS device, you can scan this QR code and it will take you to the Apple Store, and then it will install the software, or the app rather, on your iPhone there. After that, when you first open it up, it's going to ask you a question. It's going to say, what assay do you want to run? And what it will do is it will ask you to access your camera, because what it's trying to do is ask, if you expose it to this QR code, it'll be chili. If you expose it to this code, it'll be ginger. If you expose it to this code, I should have said nitrate as well, actually, because nitrate's here as well, or TAS. And we also have them coming for glucose and potassium and pH as well. So we've got 40 analytes on the standard list. Now, if you have an assay that's not on our list, you can still develop it, and you can see that we can quickly make the app run your assay by developing a new QR code for it. Something that we do as well is drop shipping. So let's say this is you, and one of the hardest things in business is not making technology, it's finding customers. But part of the value of a business is actually that customer engagement and that customer list. But there's you have a technology that's based on the SenseItAll platform. So you have clients, and the clients are placing orders with you. But how do you get them to actually get the product? So what you can do then is send your order to ZP. That's essentially an instruction. ZP receives the instruction. We put your sensor and your SenseItAll boxes in boxes, and then we ship that to what is called drop shipping to your actual customer. So suddenly the order fulfillment can be done by essentially one person just placing orders, but then in the background at ZP, there may be 5 people actually involved with the logistics of that. And I suppose a lot of what happens in business is people build up logistics, find it's actually quite hard, but they do it. But then you carry a lot of cost because you have to carry all these people for doing your logistics. Whereas here you've got a very lean business model because actually you're just taking care of the customer, which is really the value add, and not necessarily taking care of all the logistics as well. Oh, now I've got here the word demo, so I want to give Ghana a quick heads up. So what Ghana will do is she'll turn on her screen and she will share her camera and her microphone, and I will stop sharing, and then Ghana will speak for a while, and when Ghana's finished, I'll just do a quick summary, and we'll take it there. Okay, Ghana, so I'll turn off my camera, turn off my microphone, and love to hear from you, okay?
Thank you, Martin. Hi, everyone. I'm Ghana. I'm an engineer here in Zimmer & Peacock, and I'm here to demonstrate our SenseItAll platform. I'll just jump into it, and I'll change my screen. And here you can see the SenseItAll device. It's connected with USB-C cable, and it's connected to my laptop just to power it on, but it can be connected to wall socket or any other kind of power source too. So you see, the device is quite small. It fits in my palm, and I can also disassemble it like this. So there are magnets that are keeping these parts together. So I can just plug it in and can remove it for cleaning in case I spill some solution on it. And yeah, it's quite easy, just one hand gesture. And well, I'll start with demonstration. All I need to do is to press the button to turn the device. So I'll need to click the button for 2 seconds. And then I'll see that there is LED lights are blue and they are gliding, which means the device is ready to be connected to phone via Bluetooth. I have 2 types of solutions and sensors here. I have chili QR code and I have ginger QR code. I have the sensors and I have the solutions that we are testing today. And of course, I have a phone. Right now, I have Android phone, but as Martin mentioned, it could be also the iPhone. So the first thing we'll connect the device to mobile phone. I'll need to press the Bluetooth icon, and now the phone is searching for available devices. And I see that SIA2001 is available, and I can also see the part number, serial number on the bottom of the device. So that's how I know that SIA2001 is this particular device. I'll just click on it to connect. Yeah, and now it guided us back to the home screen, and we see that device is connected. It shows the device serial number and also the MAC address. Then what we can do, it's already scanned the QR code, but I'll just show it again how to do it. I'll click this QR code icon, and now you see that screen is changed and it says scan the sensor. I'll scan the chili sensor first. And we see that app is on the bottom, on the top of the screen. It's pink color, saying that it's a chili sensor, and we see some sensor batch number and part number. We also see the assay steps. In this case, in chili application, we just need to run 1 step of assay to get the results. The next thing that we need to do is the test settings. This tab is clickable, so I'll click on it. And then here we see that we have 3 inputs. The first is sample ID, then cluster name, and then operator ID. Operator ID is already filled with my name. It's by default is the email address from the jury, which is our cloud system. And now we'll just put the sample ID. Just writing like chili test. And I can also specify where I want to find it in Julie. I'll name it demo. And then when we go to Julie, we'll see that this test is saved in cluster named demo. Okay, it seems like it's ready. I can press go to save. Now we see the instructions screen. Which describes what steps we need to do. The first thing is to select dilution factor. I have Tabasco sauce mixed with a chili buffer solution with 1:10 ratio. And if you see here, I have an option 10, 100, and 1000. I'll click on 10 because my solution is 1:10 ratio. Then I will need to take the cartridge and keep it. I'll change the position so it will be a little bit easier to see. I'll keep it in dedicated space, and then I'll click it up, and we see that pins are connected to the sensor right now. Okay, now I'll just pipette some solution on top of the sensor. Usually 50 microliter is enough to cover all electrodes. I will need to mix the solution so it will be homogeneous. And now I'm trying to not touch the electrodes, to not scratch them. And also I'm trying to cover all of it with the solution. Okay, it's ready. Now I'm starting the measurement. So as we see, that measurement takes around 30 seconds. During this time, the device runs electrochemical measurement. In this case, is a cyclical thermogram. And the data is sent to the mobile app in real time. And once the data is here, it sends to the Julie, where the data is stored and it gets analyzed. And after that, the results are sent back to the mobile. And we see it on the result screen. We see that we got HSU Scoville heat unit values for 5,250, which is approximately correct, as Tabasco is claiming it's around 2,000 to 5,000 SHUs. And we also see that upload is completed, and we see that LED turned green here, which means that we can find the data in Julie. I'll just quickly go to Julie to show you how to find the data. My session is expired. I just need to log in again. Yeah, and I know that this is my MAC address. I'm clicking on it and I see the chili test, the latest test that I did. When I click on it, I will see the raw data. I will see two different scans of cyclical photometry, and I will also see how this data was used to analyze and get the results. Now I'll just go back and I will start demonstration for Ginger version. I'll click on the scan the QR code button and scan the Ginger sensor QR code. And then I see that on top of the screen it's now yellow, which is for Ginger sensor, and we see the Ginger sensor part number, batch ID, and also the assay steps. Again, the process is the same, so we'll need to put the cartridge and click it so it will be connected. And I'll change the settings to Ginger test, so it will be a bit easier to find it in Julie. And I'll click go to save. I think everything is ready. Yeah, again, my solution is 1:10 ratio, so I don't need to change it. I'll just keep it 10. And it says insert the sensor, apply sample to sensor, the next step. So I will pipette again 50 microliter of solution. And click start measurement button. In this particular application, again, it's running cyclical photometry, so we will see the similar results, similar raw data in Julie. And again, the process is really fast. It takes around 30 seconds, and during this time, it managed to run the measurement and store it, and also get analyzed values. Yeah, and yeah, it's done. And we see that upload is complete. Let's verify the device. And it's green, and we see that it's calculated around 684 milligram per liter ginger inside this solution. And when I click done, we see that light is changed to white. It means that it's ready for another measurement. I'll go back to Julie to show data. I'll just put my screen. Yeah, if I go up and then click refresh button, and now I see the ginger test is here. It's because we are in the same cluster and I didn't change it, so I can find the ginger test results and raw data here in the same cluster. I'll click on it and we see again cyclic voltammetry raw data, and we also see some peaks, and we see how it got analyzed, and we see some results and some calculations into it itself. Yeah, Martin, I think that was it.
Yeah, no, appreciate it, Gana. The reason that we like to do these live streaming webinars every month is, and there's another one on the 27th of February. So if you have people who you want to see this, the reason we do it live is because essentially it really demonstrates the robustness of technology. You know, I know that we've got, you know, somebody from industry here today and somebody from academia, and especially the industrial guys, you know that, you know, to get something this robust where actually you've got sensors working with hardware working with apps working with cloud, all the data being processed on the cloud and coming back to the app, literally. So you think it's all real time, you know, is a really, you know, that's why, you know, we've been around for 10 years, or we're in our 10th year, and it actually takes that long to get that kind of technology really working. And so I was going to say, unless you pour millions into it, but of course we have poured millions into it because we've been, you know, running and profitable for all this time. So I just want, so if people are interested in kind of doing new applications like looking at glucose or pH or oxygen or lactate and things like cell culture, we're very involved in those. So today we've talked about discrete testing because that, to be fair, that's, you know, you can see that the technology is very robust there, but we are interested in exploring more continuous applications or continuous monitoring applications as well. So if you've got colleagues and you think they might actually get a kick out of this, just tell them that there'll be another webinar. I'll put this link underneath the video as well, and hopefully they'll be able to find it, but it'll be on the 27th of February from myself and Guyana. So in summary, we're definitely trying to reduce the barriers between ideas, particularly in measurement and actually speed to market. We can get most people what we'd call a sort of minimally viable prototype within 3 months, and really no sweat. And it's really about that kind of lean startup mentality. You know, let's get products into people's hands. Then you do start finding out the real problems. The first problem might be that nobody wants what you're trying to sell, but you better find that out really quite quickly. So if you've got any questions for ZP, don't hesitate to reach out to us. I do recognize the people who are here today, so I do appreciate you coming. And just FYI, we are doing this webinar again this afternoon, but that's mostly for the people in the USA, Canada, and in South America because of the time zone differences. But I want to say thank you very much and take care. Okay, thanks very much. Thank you, Guyana. Bye-bye.